Okay, today we're going to have a look at a past HSC question for extension 2 in projectile motion, and it is the only HSC question at the moment that we have an example of resisted projectile motion. So you can expect that this is the difficulty of the HSC. Notice that this is not a quadratic drag question, it's a linear drag. Okay, now this question is massive and it takes, according to the marking guidelines, in terms of the amount of marks, it should take about 12 to 13 minutes to do this question. So I've got a particle of mass 1 kilo is projected from the origin with a speed of 40 meters per second at an angle of 30 degrees to the horizontal. Use the information above to show that the initial velocity of the particle is that. Okay, this one is a free mark. We know that it's launched with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal, which means down here we're going to have 40 cos 30, and over here we're going to have 40 sine 30. Right, now 40 cos 30, we've got V0 is equal to 40 cos 30 as a vector, 40 sine 30, which is equal to, cos 30 is root 3 on 2, so that's going to be 20 root 3, and then that's going to be 20, because sine of 30 is a half. Done. Part 1 was easy. Okay, now we've got the forces acting on the particle are gravity and air resistance. Air resistance is proportional to the velocity of the vector with a constant of proportionality of 4. Okay, so in other words, K is 4, so constant of proportionality is 4, gravity is 10. The position vector of the particle at time t seconds is r of t, and the velocity is v of t. And we have to show that v of t is that. Okay, right, our air resistance, what's going on there? Sorry about that. Okay, we need to consider our air resistance, and we're going to consider it overall first of all. So our air resistance is a force, and the force acts against motion, so it's minus. The constant of proportionality is 4, and it's proportional to the velocity vector. Now we know from the previous video that we can resolve this into minus kx dot, so minus 4x dot, and minus ky dot, so minus 4y dot. So that's my air resistance in both directions. Okay, let's consider our air resistance horizontally. We know that mx double dot, that's our force. So force over here, this is mx slash y double dot. So we're just going to leave it as force, but mx double dot or my double dot. So mx double dot in this instance is going to equal minus 4x dot. And we want to have a go at solving this. Now we're told that the mass is, let's see, the mass is 1. Right, so we're not going to have to divide by m, thank God, because it's just 1. So 1 times by that is minus 4x dot. Now to solve that, we need to replace it with dx to t, because if we have a look at what we're trying to prove, it involves time. So, oh my God, iPad's not having the best day. So this is x double dot. We might replace it with dv to t is equal to minus 4x dot. Now velocity is another way of saying x dot. So x dot, dx dot to t is minus 4x dot. And we want to have a go at solving this. Okay, there's a couple ways we can do this. I'm going to do it the way we did it in the previous video. So 1 on x dot to x dot is equal to minus 4 to t. Integrate both sides, we get ln of x dot is equal to minus 4t plus c. Okay, now we know that when time is 0, we've already proven in the previous part that its initial velocity in the x direction was 20 root 3. So that means ln of 20 root 3 is equal to minus 4 times 0, time is 0, plus c. So that means c is equal to 20 ln of 3, which means ln of x dot is equal to minus 4t plus ln of 20 root 3. which means x dot is equal to e to the minus 4t ln of 20 root 3. Okay. So let's have a think. Let's see how far we're going. Right, nice. We've got that part. That's nice and good. Let's have a go vertically now. So we know that my double dot is equal to, well, if we have a think about our movement in the y direction. Now this is projectile motion. So not only is the force in the y direction, but we've also got that gravity force. So vertically, it's going to be minus g minus 4y dot, or minus mg realistically, because it's a gravity force. Now we're told gravity is 10 and the weight of the particle is 1. So my double dot is equal to minus 10 minus 4y dot. And to have a go at solving that, we do want to get time. We want y dot as the subject, but it does have to involve time. So we might realize, first of all, okay, that mass can be replaced with 1 there because the mass is 1. So we're going to replace this with dv on dt, but v is another way of saying the differentiation of displacement, so y dot, there should be y dots there, is minus, so we're going to say this is minus 10 plus 4y dot. Okay, let's have a go at solving this. Now this is not as straightforward to solve. Again, we're just going to treat y dot in this instance as a variable, like we did in the previous solving for x. So we're going to say 1 over 10 plus 4y dot is equal to minus dt. Now, in an ideal world, we want a 4 on the top. So we need to put a 1 on 4 over here. So this is going to be 1 on 4 ln of 10 plus 4y dot, and that's going to equal minus t plus, positive, minus t plus c. Okay, let's have a go at using our initial conditions. So we know that when time is 0, we've decided that y dot, I think we said was 20. Let me just go and remind myself. Y dot was, let's see, 20. So substitute that in. 1 on 4 ln 10 plus 4 times 20 equals t is 0, so that's c. Now 10 plus 80 is 90, so this is 1 on 4 ln 90 is equal to c. So therefore 1 on 4 ln of 10 plus 4y dot equals minus t plus 1 on 4 ln of 90. Multiply everything by 4. Got ln of 10 plus 4y dot equals minus 4t plus ln of 90. Raise everything to the e. We're going to get 10 plus 4y dot is equal to 90 e to the minus 4t. Minus 10 over and divide by 4. So y is equal to 90 on 4, which is 45 on 2. And then 10 divided by 4 is 5 on 2. Which I think is what we wanted to prove. Yeah, so therefore, v of t is equal to 20 root 3 e to the minus 4t, and then 45 on 2 e to the minus 4t minus 5 on 2. That one wasn't that was quite an easy question there, not too bad there. Okay, let's have a look at the next part. Part 3, show that is r of t, right. So we're probably thinking we're going to have to integrate both of these functions. Now we do know that displacement is the integral of velocity. So let's find the integral of velocity. The integral of, or 20 root 3 integral e to the minus 4t to t. So that's going to equal 20 root 3 on minus 4 e to the minus 4t. And we are integrating, so plus c. Now let's think. We've got to think when time is 0, well, we're starting at a displacement of 0 because we're starting at the origin. So t equals 0, x is equal to 0. Now that's going to make c equal, 0 is equal to 20 on 4 is 5. So that's 5 root 3. E to the 0 is 1 plus c. So that makes c equal to 5 root 3. That's a minus there. So therefore my x equation is minus 5 root 3 e to the minus 4t plus 5 root 3. And if we want to take out a factor of 5 root 3, it's going to be 1 minus e to the minus 4t, which is actually what we were trying to prove in the x direction. Now we do know y is the integral of y velocity. The integral of velocity with respect to time is displacement. So we're going to integrate 45, not as pretty to integrate, onto e to the minus 4t minus 5 onto to t. Now 45 on 2 divided by 4 is 45 on 8. So minus 45 on 8 e to the minus 4t minus 5 on 2t plus c. Now we know that when time is equal to 0, y is equal to 0 because it starts at the origin. So 0 is equal to, that becomes 1 when we raise it to the power of 0. So minus 45 on 8, that dies when we make it equal to 0, plus c. So c is equal to 45 on 8. So therefore, and I just might notice now we're being realistic. We've currently gone over the time that we would be like, we've gone over by about 20 seconds how long you need to take to do this question. Yes, I am explaining it, so in an exam it wouldn't take you this long, but just so you're aware, we're now over the time that you kind of allocated to do this question. Mind you, we have almost finished, so that's pretty good. Now we want to see what we are taking a factor out of. So we're taking out a factor of 45 on 8. So 45 on 8. We're not taking it out of everything. We're just taking it out of him and him. So if we pull out this one first, it's going to be positive 1. So 1 minus e to the minus 4t. Rightio. So therefore, we've actually proven it. R of t, which is our displacement vector, is equal to 5 root 3, 1 minus e to the minus 4t, and then 45 on 8. Bam. Okay. Last part hasn't been too tricky so far. Let's see how the last part, I think, it's been noted in the marking that this was the most difficult one. So we've got the graph shows 1 minus e to the minus 4x, which we might note is in green, that and that, and y equals 4x on 9. I'm not quite sure where 4x on 9 is coming from. Use the diagram to find the horizontal range. Okay. Well, let's think. Horizontal range is when y is 0. So we want to know, okay, horizontal range occurs when y is 0. So we want to know the time when y is 0. So the equation of y is 45 on 8, 1 minus e to the minus 4t, minus 5 on 2t. Now, importantly, if you didn't get the other parts of the question, I'm feeling like this one is a free mark, basically, because you don't need to use the other parts to get this one. So you do need to use other parts to get this one, but they're given to you. So if you can just use the previous parts, even if you couldn't get them, then you're going to be able to get an answer for this one. Okay, Let's have a go at solving these. So we've got 45 on 8. Oh, not. God. What's going on? 45 on 8. 1 minus e to the minus 4t is equal to 5 on 2t. Now, if we divide the 45 on 8 to the other side, let's try that. 45 on 2. 5 on 2 divided by 45 on 8. We get 4 on 9. So 1 minus e to the minus 4t is equal to 4 on 9t. Now, we were wondering before where on earth did the 4 on 9 come from. We've just discovered it. So there we go, 4 on 9, and that's the right-hand side of the equation we just had, and that's the left-hand side. And the intersection is 2.25. So we've decided that on the graph. So the solution to this equation right here, which we're not sure how to solve, is 2.25. I'm going to say from the graph. Right, so the range occurs at time is 2.25, and we're just going to substitute that into my equation for x. So the equation was 5 root 3, 1 minus e to the minus 4t. Substituting in that value of t, you'll get about 8.7 meters. All right, thank you.